Work and Energy. Part 3. Forms of Energy. Potential Energy. In the previous video, we learned about kinetic energy. In this video, we will learn about potential energy. Now, let us have a look at some simple examples to understand potential energy. Hold a rubber band in one hand and pull the band with the other hand. The rubber band will get stretched. Now, release the rubber band from one end and you will see that the band returns to its original state. Why do you think the rubber band returned to its original state? It is because the band acquired energy when it was stretched. And this energy causes the rubber band to return to its original state. Now, take a toy car and wind it with its key. Then place the car on the ground and you will notice that the car starts moving. From where do you think the car got the energy to move? In all of the instances, the objects stored the energy from the work done on them. When an object doesn't use the energy transferred to it to cause any change in its speed or velocity, then it is stored by the object in the form of potential energy. You transfer the energy when you stretch the rubber band or wind up the key of the toy car. When you stretch the rubber band, the work done by you in stretching it is stored in it as potential energy. And when you wind up the key in the toy car, which compresses the spring inside it, the work done in compressing the spring is stored as its potential energy. Now, let us perform a few simple activities to understand potential energy. Take a ball and raise it to a certain height. The ball now has the capacity to do work. Then release the ball and you will notice that it begins to fall. Now, what do you think will happen if you drop the ball from a greater height? The ball that falls from a greater height will have a greater velocity when it reaches the ground. We did more work on the ball when we raised to a greater height. Thus, it possesses more energy. Now, take a bow and an arrow. Place the arrow on the bow with one end supported by the string. Now, stretch the string and release the arrow. You will notice that the arrow flies off to a certain distance. The bow stores the potential energy when the bowstring is stretched. And then this energy changes to the kinetic energy of the flying arrow. Now, let us understand what happens to the potential energy of an object when raised to a certain height. When an object is raised to a certain height, work is done on it by us against gravitational force, due to which an object possesses more energy when raised to a greater height. This energy possessed by the object is termed as gravitational potential energy. Gravitational potential energy is defined as the work done in raising an object from ground to a certain height against gravity. Now, let us derive the mathematical formulae for gravitational potential energy. Suppose an object with mass m is raised from the ground through a certain height h. The force required to raise the object is equal to the weight of the object, that is mg. The energy gained by the object is the work done on it. Let work done on the object against gravity be W. W is equal to force multiplied by displacement, which is equal to mg multiplied by h, which is equal to mgh. As the work done on the object against gravity is mgh, so the energy gained by the object is mgh, which is the potential energy of the object. Therefore, potential energy of the object EP is equal to mgh. When an object is raised to a certain height, then the work done on the object depends on the difference between the vertical heights of the initial position and final positions of the object, and not on the path taken by the object. Take a look at these two images, where two objects take two separate paths to reach from position A to position B. Here, AB is equal to h. In both the cases, the work done on both the objects is mgh. Now, do you know if energy can be converted from one form to another? There are various examples of energy conversion available in nature, like the water cycle or the process of photosynthesis, using which plants prepare food. Now, let us have a look at some examples of human activities that involve energy conversion. In the bow and arrow example we studied earlier, potential energy is stored when the bowstring is stretched, and it is used in the form of kinetic energy to throw off the arrow. Another example would be a running car, where chemical energy of the fuel is converted into mechanical energy, which aids the car to move. Now, can you give some examples of human activities that involve conversion of energy? Think about it. In this video, we learned about potential energy. In the next video, we will learn about the law of conservation of energy.